Okay, so I have these two functions defined in GC, f and g, and then I'm showing a graph here. So what am I displaying here relative to the functions f and g? What's that? Okay, so what about relative to the functions f and g? What am I displaying relative to the functions? And actually, if you would not have GC open during this, that would be good. So at the end, you'll have a little bit of time to mess around on GC relative to this, but don't be on GC during this activity. So what's being displayed relative to functions f and g, do you think? Eunice said x squared. What's that? Okay, so am I graphing f of a? Yeah, sure. Yes, right. Okay, good point. So, so right now is when you have the conventional view of x and y. So let me just tell you again here. Right now is the conventional view of the xy plane. So. So, what about this? What about that I'm graphing f of a? Is that right? Everyone agree that that's what this is? The graph of f of a? What's a? So is this the a-axis?
No, it's x-axis, but you're substituting, referring to it. So you're showing x.
So what's being displayed? Is f of a being displayed? F of x, right? F of x is being displayed. So what's the deal with a?
X is being substituted in.
Okay. Yeah. Remember what we talked about at the beginning of the course? What was? A is what? A particular value? So there's just like 1? Like f of 1 equals 1 squared? Do you remember what we talked about at the beginning of the course with this? And what does that mean? Yeah, right. What does that mean, a dummy variable?
Placeholder.
Placeholder for what?
A function. For whatever you want it to be. Because we can put a equals and then make it.
Right, so we can make it any letter we want. But what specifically is it a placeholder for? X or Y? What's that? Okay, right. The independent variable of this function, right? The independent variable of this function. If I want to graph that function, then we're going to say the independent variable is x, right? So this is worth reviewing here. So if I had put f of c equals c squared, what would be different? Nothing. If I put f of g equals g squared, what would be different? If I put f of x equals x squared, what would be different? Nothing. These are all, it's just a placeholder for the independent variable. Then when I graph it, we know this is the x-axis, right? So I'm going to graph the function f of x. So that's a review, but I think it stands to review that. So this is the graph of y equals f of x. We got a y-axis and an x-axis. Okay. So now I'm going to put right here, I'm going to call this x naught. Okay? So that's a particular x value there. And then this is in the xy plane. I'm going to draw up to there. And I want you to represent in as many ways as you can that what that vertical segment represents. So you can brainstorm at your tables. Represent the length of that segment. Okay. Did you guys come up with just one representation of that distance? Well, what's one of them, Jessica? So, yeah. Oh, that's 2. That's 2, right? Yeah. So she said f of x naught. What do you think? Is that a representation of that distance? F of x naught?
Basically, yeah.
Basically, or yes?
Yeah.
Yeah. Okay. What's another representation of that? Did you guys come up with a different one? F of x naught? dy? Okay, so now relative to the variable y, is it really a dy? So yeah, so we could say it's a dy, but relative to the variable y, what's maybe a more I don't know what we're not looking for here, but maybe a more suitable choice. What's a more relative to y? What's a more suitable choice? No, relative to y. So in terms of y. Okay, and what is y initial? 0. So therefore, just y, right? Just y, or why not? All right. So you can say why not, or just y. Okay. So yeah, it is a dy. It is a dy from 0, but kind of more suitably, it's just a y coordinate, right? Because it's the distance from the x-axis. Okay. Any other ways to express it?
He said x naught squared.
She wants x naught squared. Does that express that distance? Brandon likes it. Yeah. So those are all valid representations, and let's put dy in there. That's fine. Those are all valid representations of that. F of x naught squared, y naught, dy. Okay. Easy, right? So far. Okay, let me show you this. Okay, so now I want you to discuss what does this graph represent? Okay, what does the curve have to do with f, g, x, y, and z? Okay, so what does it represent, and what does the red curve have to do with f, g, x, y, and z? Is that a good view? So yeah, let's go with my second question mostly. So relate that graph to each of these. Okay, so talk about each of these in relation to that graph. F, G, X, Y, and Z.
So F is the input, G is the output.
F and G are functions. F and G are functions. They're not input or output. They're not variables.
What is F of G? Well, technically it's G of F in this case, isn't it?
Okay.
Isn't that still input or no?
Okay, but kind of stick to my question. My question is, for each one of these, what does this have to do with the curve? What does the function f have to do with the curve? What does the function g? What do the variables x, y, and z have to do with the curve?
So what about F and G?
Well, F is the first extrusion.
So the red graph, is it a graph of either f or g, first and foremost? So is it, can you say it's a graph of either f or g?
It's a composition function.
Okay, so, but is it a graph of either f or g?
By itself, no. Actually, it's of G.
What's that?
It's of G.
It is of G.
Okay, yeah, this is a graph of g, okay?
Of G, just with different G.
So it is Y, Z equals G of X.
Okay, so this is a graph of g. And so how is it displayed as, what's displayed as independent and what's displayed as dependent? So what's the independent variable, x, y, or z, and what's the dependent variable, x, y, or z? Brittany.
Y, I believe, is being independent variable for G.
She's saying that y is the independent variable for g. Agree? Disagree? Disagree. Leo? Disagree. So independent. What about dependent? Can we agree on that? Okay, so you guys agree on that? So the dependent variable is z. And so we're still not sure about the independent variable. So those who think it's y, make your case to those of your table. Those who think it's not y, you make your case. So let's try to come to consensus. What is the independent variable of this graph? Y or x or something else? Okay?
Yeah, which in the sense is
And in order to answer this question, what I want you to do, sketch sine of 3b. Just sketch sine of, if you were to do y is g of x. Sketch y equals g of x, and then I want you to think about that graph and then think about what you're looking at. You don't need to. The idea was to sketch it without technology. Sketch y equals sine 3x without technology.
Is that better? Is that 3 in every one? 3.
Okay. So let's kind of show an analogous amount to what you're seeing on the screen, right? Show an analogous range, I guess. So draw a range that's similar to the range that you're seeing for this graph.
So like 0.5?
No, just number of cycles, right? Number of cycles. You just need like 2 cycles on either side of z, or in your case, y. There's something I'm getting at here for you to compare y of g of x to the red graph that you're looking at.
like a regular sine graph would be why is that line right there? It's like it's making like a sort of curve over it. And remember we can have like one input has to have a single output.
This makes a lot of sense.
If it was y, then it should be over.
Okay, how do we do? So,
I don't even know if this is I don't know if this is
do you think the independent variable is x or y? People are saying y now. Okay, so my question is, why? How is? Does this look like the graph of g of x? What's different? Right, for values of x less than 0, g of x starts negative, right? And then heads back up and then continues to cycle. But this, what does this do? When x turns negative, it goes up positive. So how does that agree with the fact that it's g of y?
Because for the function f of a or f of
Okay.
x, it's a parabola, so all your y values are positive anyway. So
Okay.
that means it's always going to be a positive value.
Sophia likes it. Jesus. So if it was g of x, then what would we expect? The same graph that you saw, right? Going negative. But if it's g of y, then all these y values are what? They're positive, not negative, right? They're positive, so that's why we're getting a mirror reflection of this side. Because we just like we put in all positive independent variable, well now we're starting again and going this way with positive independent variables, so we get this reflection over the z-axis. Okay. Cool. So now, any questions or discussion on that? All right. So this is the intersection right there, that, and this is, we're going to call this x1. Okay, and I want to I want you to find the value of x1. I want you to find the value of x1.
The exact value or the
Exact, yeah.
Let's just take the negative out.
So I'm calling it x1. But so it's like if you start at the origin and you say, yeah, there's multiple places where it's 0, right? So I'm here. And there's multiple places that it's 0. Well, which one is that? Moving from the origin, which one is it that you need? The first one. Yeah, the first one. So you know which one it is, right? So.
He does that every time. He's kind of like pause. Right?
Okay. Almost. Almost.
Valid people's failure.
Okay, seems like all the tables are either got it or very close now.
Well, you make it to the top of the mountain or you hang it off the I'm just kidding. I'm joking.
Okay, so can anyone like talk me through this kind of in a reasoning way, not in a like algebraic plugging and chugging kind of way? So yeah, we're gonna need algebra to solve it, but can we talk it through in a reasoning type of way? Anyone? We could do that. So where do we start here? Where do we start? Z is equal to 0, right? That's a good start. Z is equal to 0. And what did we say Z was?
G of f of x, basically.
G of y, right?
Sure.
Okay, and where do we go from there? So we want, and what is G? Okay, can you put that away? And what is our function G? Sine of 3b? 3y, right? 3y. Not 3b, right? It's nothing to do with b. B is just a placeholder for the independent variable. Our variable is not b, right? It's just, in that way we define it, it's just taking the place of the independent variable. When we graph, we want, our variable is y. Y is what's varying. Okay, so where do we go from here? So we want 0 equals sine 3y. So our y is x squared. Okay, so we're asking the question, when is sine 0, right? We're asking the question, when is sine 0? When is sine 0? Okay, so try to avoid just the variables in the algebra and like let's reason it through. Yeah, Sophia.
So if you were just like looking at like sine of 0 when like you have sine of negative pi, sine of 0, sine of pi.
Okay.
And then so to get, since it's sine of 3y, you would do pi over 3.
Okay, so where would you come up with pi again? One more time.
Because the way like a sine like function works.
Right.
Sine of 0 occurs periodically.
Right.
And it will happen at 0, pi, negative, and it can go the other way in like both directions.
Right. So right, there's lots of values that give sine value of 0, and so the question is, which one do we want? Which one do we want? the first one, right? So we want that one. And so that's if the first time we get 0 is sine of pi, then you were taking it from there.
Yeah, so then you have to do pi over 3. You have to be, y would have to be pi over 3, so that way your 3's would cancel out, and you'd be just left with sine of pi.
Right. So 3y is going to be pi, right? So we need 3y to be pi to get the first 0 starting from the origin. Okay? Someone take over from there. So did you guys correct your response? Did you get it in the end? Yeah, sure.
Okay, so now that you know what y is, since we already said that f of x equals x squared and that equals y, you would plug pi over 3 into x squared, or well, not into x squared, but it would be pi over 3 equals x squared.
Right. So yeah. So we said. So there's. This would be pi over 3, right? Okay. So then the x that would give us pi over 3 when we square it is? Okay. So kind of maybe guess that it's negative. Is it negative or not? Yeah. Oh, why did that happen? That shouldn't have happened. But I did not hit that. Whoa. Okay, so there we go. So we came up with, what was the x value we came up with? Negative square root pi over 3. Okay. So I want to pick this point right here. So now I'm going to call this x value x2. So I want you to represent now this in as many ways as you can. So does it look, that's supposed to be vertical. Does it look vertical? So it's a little better. So see, vertical is actually a little bit tipped. So this vertical, that's vertical. So I want you to represent that in as many ways as you can. There are many. I'll just tell you right now, there are many. So given this value is x2, represent that vertical distance right there in as many ways as you can with the symbols that we're using. Go. 1, 2, 3, 4. So I have 5, but there could be more than 5 too. There could be more. All right, just give me one. G of f of x2. Other tables agree? That's definitely a good one. All right, you guys, what's another one you guys came up with?
Sine 3 of x2 squared.
Sine of 3 times x2 squared? How about that? Is that valid? Very good. Okay, you guys, pick your favorite of your mighty list.
Sine 3 f of x squared.
Sine of 3
Oh, not x squared, sorry,
f of x2.
x2.
Like that? Does it work? Okay, good. You guys are up. Yeah.
G of y of x2.
G of y of x2?
Yeah.
Y is not a function.
We wanted to
Y is a
specify the
variable.
we wanted to specify the specific value of y at x2.
Right, and what would that be?
Oh, we've written it as y sub x2, but
You could just say y2.
okay.
We'll just say
Sounds
y2.
good.
Yeah, but it's not a function, right? Y is not a function, it's a value. So G of y2, okay? Do you guys have a different one or no?
No, not really.
What? I heard something. No? Okay. Z? Z2? It's a Z coordinate? All right, you guys, is there one? There has to be one you don't. You got 1, 2, 3, 4, 5. What else?
Okay, we want
What's that? So it could be DZ, yeah. Change in Z. You guys have another one?
sine of 3y2.
Sine of 3y2. Anybody have a different one? What are we up to now? 7? Anybody have one that's not on that list?
G of x sub 2 squared.
G of x sub 2 squared. Does it work? I think it does. Any others? So that's what? 8?
Yeah.
Nice job. Okay, so as you discovered then, all values of Z are how related to f and g. All values of Z are how related to f and g. So how could you define all values of Z on the red curve? Most of you already discovered that, but I just wasn't. No, you don't want to say it. You were saying it the whole time, and now you don't want to say it. Yeah.
Z equals G of f of x.
G of f of x. Okay, and so we really got a new function, right? We really got a new function, so we could just name this. We could say, okay, x is independent, and to get z, we could just say make a new one, h of x, right? Is it fair? So there's some single thing, h, that when operating on x would give us z. What would the function say if I came up here? Then what would say h of c be? Maybe talk about that. Then you say, what is h? What is the function h using the dummy variable c that gets us streamlined version from x right to z, right? So given any x value, it would give us the z value of the red curve in one rule rather than going through 2 rules. So what would h of c be? So Eunice, what'd you say?
Sine 3 of c squared.
She wants sine of 3c squared. Okay. Good. So now, so this is really all about composition. what is the composition? Is it g of f of x or is it h of x? Is the composition g of f of x or is the composition h of x? Which is it? Which is it? She's saying it can be either. Both are considered a composition. Sophia likes it. Rachel likes it. So let me show you something. So I'm going to take the let me actually turn off this one. Okay, so there's this graph, right? So if I turn and look at just the xy plane, here's x and y. What do you see? The function f, right? And so in the xy plane, we get the function f. What if we turn and look at let's see, I want to get this right here. So yeah, this way. I'm going to turn and look at the it's kind of hard to control. So now what plane am I looking at now? This is the right. This is the y-axis, right? And this is the. So now I'm looking at the YZ plane. And what do you see? Right, just G. And then if I turn and look at maybe let's up a little bit. What is this? So what plane is this now? XZ. What do you see when you look at the XZ plane? What's that? Is this H? What was H again? Okay, but do we see it? Do we see the composition anymore? What do we see? When you see this, you just see Z equals H of X, which is our sine of what? 3x squared? So when we said the composition was Z is H of X, algebraically, that's this rule right here. Where did Y go? Do we have Y anymore? Y is gone. So if I take Y out of the view and just show the ZX plane, I just simply see this function Z, this Z equals, or yeah, sine of 3x squared. So this is one way to think about the composition, the streamlined rule, right? That eliminates the middleman, right? We eliminate the middleman, which was Y. And so we just show sine of 3x squared as just the relationship between x and z. Or I can show the version that includes the middleman, right? So what am I showing now? By showing all three, this is now y, x, that was still x, and this is y. So now I'm showing all three variables, and which version of the composition am I showing now? Yep, so then what function, how does my view agree, what form of the composition functions agrees with my view now? Yeah, g of f of x. So since f was graphing y as a function of x, when you look at the xy plane, all you see is f. Since g is graphing what? We're graphing z as a function of y for g, then when you look at the yz plane, all you see is g. And then since h is our streamlined version of the composition, takes out y, when you just view x and z plane, you just see 3x squared. But then this view shows the whole thing, right? It shows the two-step version of the composition. Because first you have x, which gives you y, and then g gives you z.
So you're saying it changes based off of what you want to see.
So what I'm saying is there's two ways to talk about the composition of f and g. You can talk about it this way, h of x, and you can talk about it this way. And that is in agreement with the way that you view the graph, right? If you just view the zx plane and you take y out of the view, then you're going to get this version of the composition where we took y out. If you show all three variables, then you're seeing this version of the composition. A two-step version, right? X first, then y, then z. So it's a way to talk about composition using three-dimensional coordinate space. So, just like in R2 when you were graphing points or parametrics, you did control 2. So in R3, you just do control 3. So can you, in 5 minutes, reproduce my file? So just like when you did parametrics in R2, you did control 2, and that opened the 2 vector. If you do control 3, it opens a 3 vector. So see if you can reproduce. This graph in GC.